Welcome back, Algebra 1 students, to another Regents exam. This is going to be the Algebra 1 Common Core Regents exam for August 2017. Not too bad of an exam, if I must say. These are going to be the solutions to Part 1, which are the multiple choice questions 1 through 12 of this exam. Before we begin, let's talk about a couple things. As usual, do not take these answers, the multiple choice work, I should say, and hand them in for a homework grade, or if you need it for some assignment, or you need it for a take-home test, or whatever it might be. You need to try the problems by yourself. Algebra 1 is not that difficult. You could do it. So please don't cheat, because this Regents you do need for graduation. Okay, make sure to hit that subscribe button down below. Consider becoming a patron on my Patreon page. $1 donation from you could keep this channel going forever. And I will be forever so grateful if you decide to do it. If not, that's okay, because I provide these free of charge anyway. And make sure that you visit my website at www.nysmathregentsprep.com for more math content in Algebra 1 and future mathematical subjects. And I use the TI Inspire CX calculator for this Regents exam for Algebra 1. Actually, I use it for every Regents exam. Just so happens that I use it a lot for Algebra 1. Okay? I would consider buying this if I were you. You can find the link on my website. It links you directly to Amazon. I have nothing to do with the calculators. All right, without further ado, let's begin this exam. So the first question is actually pretty simple. We begin with an easy one. Number 1 says, a part of Jennifer's work to solve the equation 2 times 6x squared minus 3 is equal to 11x squared minus x is shown below. So this given is the same as the top, and she performs an operation in step 1. Which property justifies her first step? So something's going on from here to here. Well, what is the difference between the blue line and the pink line? Well, clearly I see something going on here with a 12 and a negative 6. That is not the same thing as up here. We have a 6 and a 3, and we got that 2 out front. So what is Jennifer doing to get from the blue to the pink? Well, clearly she's doing what's called the distributive property. She's taking that 2 and she's multiplying it or distributing throughout the parentheses. So the 2 times the 6x squared and the 2 times the negative 3. Well, 2 times 6 gives you 12. Carry along that x squared for the ride. And the 2 times the negative 3 gives you a negative 6. So which property justifies it? Not the identity property, not the multiplication property, not the commutative property. It is the distributive property of multiplication over subtraction. Over subtraction just means that she's just distributing that number, and it just so happens that inside those parentheses, these two terms are being subtracted from each other. That's basically what it means. They could have just put the distributive property, and that could have been an answer too, but anything that just says distribute would have been your answer. In this case, it's choice 4. Moving on to number 2. All right. It says, number 2 says, which value of x results in equal outputs for j of x equals 3x minus 2 and b of x equals the absolute value of x plus 2. So there's really 2 ways you could do this. Either you could solve this algebraically or solve this graphically. I'm going to show you both ways. So I'm going to do it algebraically first. The algebraic way is to take j of x equals 3x minus 2 and set it equal to b of x equals the absolute value of x plus 2. And they're asking you for equal outputs. Okay? Equal outputs, meaning that what value of x would make these two functions equal. So in order to do this, you take 3x minus 2 and you just set it equal to the inside piece of x plus 2. So we have 3x minus 2. That is equal to x plus 2. Solve for x. So I'm going to add the 2 on both sides. We get 3x equals x plus 4. Subtract the x on both sides. We get 2x equals 4. Divide by the 2. And we get x is equal to the number 2. Your answer is choice 2 for that one. Now, to show it graphically, go to your graph page. You're just going to type in 3x minus 2. And you're going to type in the absolute value of x minus 2. Was it minus or plus? I think it was plus 2. X plus 2. Yep. Okay. Graph those. Clearly, they intersected this portion over here. And menu, analyze graph intersection. You could click on that, and your x value for this one is right there, the 2. All right, and your answer is choice 2. All right, moving on to number 3. The expression 49x squared minus 36 is equivalent to what? So this is just a basic factoring question. So what we need to do is do the GCF, greatest common factor, followed by the difference of two perfect squares, followed by the trinomial method, which is the AM method of factoring. So, honestly, I would take out a GCF here first, but unfortunately none of the answers show that, and I don't think there is a GCF. No, there is no GCF for this. So, we just do the difference of two perfect squares. So 49 is a perfect square, x squared is a perfect square, and 36 is a perfect square, and it's subtraction, so we know it's the difference of two perfect squares. So the square root of 49 is 7. I'm going to set up my double bubble. Square root of 49 is 7. Square root of x squared is x. Square root of 36 is 6. Just add that plus minus in between, and that is your answer. Your answer is choice 3. All right, moving on to number 4. If f of x equal to 1/2 x squared minus, in parentheses, 1/4 x plus 3, what is the value of f of 8? So essentially what they're saying here is take that 8, which is your x value, and plug it into that and see what you get. Okay, that's not too bad. So we have f of 8 is equal to 1/2 times 8 squared minus, in parentheses, 1/4 times 8 plus 3. All right, let's go ahead and simplify this. So we got f of 8 is equal to 1/2 times 64 minus, in parentheses, 1/4 of 8, that's just 2 plus 3. Okay? F of 8 is equal to, let's see here, we get 32 minus 5. And that will yield a result of the number 27. That is your answer. Your answer is choice 3. Now, if you want to, you could also go ahead and graph this, because this actually is a quadratic. So if you graph the quadratic and you click on your table of values and go down to 8, you'll get the answer 27. All right, that's another way to do it. All right, number 5. The graph below models the height of a remote control helicopter over 20 seconds during flight. Okay? Over which interval does the helicopter have the slowest average rate of change? In other words, which of the following has, we could say that the slope is not steep. So where is the slope not steep? Okay? So if we take a look at all of these lines, from 0 to 5 seconds, okay, from 0 to 5 seconds, that looks like a pretty steep slope, regardless if it's negative or not. It doesn't matter if it's negative or positive. It's just asking you for the steepness. That looks pretty steep just by eyeballing it. This doesn't look like it's going far. That green side, that doesn't look like it's going up very high. Then all of a sudden it drops down. That looks steeper than the green. And this looks a little bit steeper than the green as well. So your answer is probably from the interval of 5 to 10. It's probably that green spot. So that is going to be your answer. Now, here's the thing. I was a little lazy for this question. You could clearly see that it is not the steepest slope. If you want to calculate each individual slope, I applaud you for that. That's perfectly fine. But this is an accurate enough drawing that you could clearly see, and they give you the points as well, that you could clearly see. Look, it's going from 519 to 1020. That y value is a jump of 1. Then it's going from 14 to 17 over here. That's a jump of 3. Okay? Then it's going from 20 to 14. That's a jump of -6. Then from 46 to 19, that is a jump of, oh god, I can't do simple math. 20, -20, 46 minus, why can't I think of it? 26, oh, sorry, -27. Duh. Okay? So, clearly that's not steep at all. So your answer is going to be choice 2. Number 6, in the functions f of x equals kx squared and g of x equals the absolute value of kx, k is a positive integer. If k is replaced by 1/2, which statement about these new functions is true? So essentially what they're asking you, and this is kind of a dilation question, because it is, they're saying if you take this 1/2 and you plug it into k, what happens? Okay, I'm going to go to my graphing calculator. They told us that the original graphs were x squared and the absolute value of x. Okay, so we have these functions. Now, what they're saying is take 1/2 and plug them in like this. So 1/2 x squared. And then we got, I did it again. Shoot. The absolute value of 1/2 x. All right, I'm actually going to make these a little bit cleaner in terms of the line color. So I'm going to make this blue. I'm going to make the new one blue. I don't know why that's multi-select. Oh, God, this calculator. Sorry, it's just my computer. My computer's not... I have a interesting software that I'm using. I don't know what's going on here. Okay. Obviously, this isn't working as well as I planned. But essentially, you're looking at this one to this one, and then the pink to the orange. As you can see, the graphs are getting wider. Oh, can I actually change this now? Oh, nice. Okay. Hold on one second. Let me change this. I'm going to make this red. No, I'm going to make that pink. Pink or magenta. I'm going to make that red. I don't know why all of a sudden it started working. Okay, so this graph is the pre-image of this. So as you can see, these graphs are getting wider. They're not shifting up or down, left or right on the graph. They're just getting wider. So your answer is choice 1. The graphs, both of f of x and g of x, become wider. Easy enough. That's the best thing to do. Graph it, see what it looks like. That's choice 1. Number 7. Winona? Okay, I guess. Winona sketched the polynomial p of x as shown in the axes below. Which equation could represent p of x? Oh, man, I remember this question, and I don't like it. So, you need to be very careful here. This is what's called a cubic function. Let me explain what that is. A cubic function has 3 roots. In other words, the graph or the function crosses the x-axis a total of 3 times. Okay? But, you could tell that it's a cubic function because a quadratic looks like this. Okay? It's not a quadratic. And let me explain why I'm saying all this stuff. Look at your answers. Look at your answers. Choices 3 and 4 show a quadratic function because if you just simply FOIL or distribute, you're going to get an x squared term in both of these. And as you can see, there's only 2 binomials. Look at these answers. One of them has a squared as its power. So in other words, choice 1 could be written as x plus 1, x minus 2, x minus 2. It's actually foiling first, then you distribute again. So this will give you an x to the 3rd term, both of these equations down here. Okay? So essentially what you're looking at is you're saying, okay, how do you know that it's 3 roots? Trevor, I only see there's 2 things. There's 1 and there's 2. Shouldn't it be a quadratic? And the answer is no. The reason why the answer is no is because this root over here has what's called a multiplicity of 2. And you're probably sitting there thinking, I don't remember learning multiplicity in my algebra class. And that's probably because you did not learn about multiplicity. Let me explain what it is, and this will take a couple minutes. There are 3 types of roots in the mathematical worlds that you should know about in terms of graphing. And there are funky names for them, but they're really not that hard to remember. So I'm going to draw 3 x and y axes, okay? As you know, this is a line right there. And it crosses the x-axis at one point. I call this a cut through. Okay? Since there is one specific root, this has a multiplicity of 1. Meaning that is the root, that's it. There's no more than that, just that one root. Then all of a sudden, there's this thing called a parabola, and if it touches the x-axis or it does this little bounce, I call this a bounce, this has a multiplicity of 2. That's where I'm getting the multiplicity from. If you actually just ignore these pieces over here, this is a mini quadratic. It's bouncing off of the x-axis. So this is x equals 2, but it's really counted twice in your answer. That's what multiplicity is. It's the relationship between the characteristics of the graph and how many times the root repeats itself. So let me show you the last one. The last one is actually, it slithers through the x-axis, so I call this a snake through. And as you would assume, this has a multiplicity of 3. Okay? So that's all you need to know about what multiplicity is. So if you go back to the question, and if you want to figure it out, we clearly see 3 roots. Even though we only see 2 on the graph, this one counts 2 times, and this one counts one time. So there's 3 roots. And if you picked one of these answers, choice 3 or 4, you fell for the trap. You thought it was a quadratic. It has to be either 1 or 2. So now what we're going to do, these are the polynomials. We always know that the polynomial factors are the opposite of what the roots are. So in this case, this root is x equals -1. This root is x is equal to 2. So your factors are x equals, no, I'm sorry. Your factor is x plus 1, and this is x minus 2 squared, counting for those 2 other terms. Your answer for this one's going to be choice 1. Now, let's just say you knew none of what I was talking about. It's a very simple question to just go to your graphing calculator and graph all of it. So if I go to my graph and you type in x plus 1 and you type in x minus 2 quantity squared, that is a clear representation of the graph that is shown right next to it. Okay, so that's how you do that question, either graphically or algebraically or conceptually. Okay, that's number 7. We're moving on to number 8. Which situation does not describe a causal relationship? A causal relationship. All right, so let's take a look here. Choice 1 says the higher the volume on a radio, the louder the sound will be. Well, if you raise the volume knob on the radio in the car, will the sound get louder? Yeah, so that is a causal relationship. If you turn the dial, the volume goes up. If you do something to the knob, something happens to the volume. So that is a causal relationship. Number 2, the faster a student types a research paper, the more pages the research paper will have. Okay, so if you type the paper faster, does that necessarily result in more pages? And the answer is no. So if I were to tell you to write an essay on scrap paper first, and you have 10 sheets of loose leaf, okay? All you're going to do is you're just going to take your 10 sheets of loose leaf, you're going to take all those words that you wrote, put them up on a nice, clean Microsoft Word document, and you get, let's just say you get five pages, because we all know that we write bigger than we type. So you get a result of 5 pages. That doesn't mean that you're adding more material. The faster you type, the faster you type it, you have more free time. You could go watch TV or something. You can go on your phone. I don't care what you do. But it doesn't mean that you're getting more pages just because you type faster. Okay? So your answer is choice 2. Choice 3 shows the shorter the time a car remains running, the less gasoline it will use. Absolutely, because if you turn the car off, it's not using any gasoline. And the slower the pace of a runner, the longer it will take the runner to finish the race. Yeah, if you're running 5 miles an hour, you're going to finish a little bit later than the person who's running 10 miles an hour. So your answer is choice 2 for that question. All right, moving on to number 9. A plumber has a set fee for a house call and charges by the hour for repairs. The total cost of her services can be modeled by C of t equals 125t plus 95. Which statement about this function are true? So, let's take a look and analyze this equation. So, it says she has a set fee for a house call. So, before she even gets to the door, she needs to get to your house first. What happens is the plumber charges you $95 for the house call. Okay? So you call her up and say, hey, I got a problem with my toilet. It's backed up. Can you come over? She'll say yes, but I charge $95 to go to your house. Just as soon as she steps in the door, boom, $95 in her pocket. Then what happens is she charges $125 for the amount of hours she works. So the amount of hours in this case is represented by the letter T. So she could work for 2 hours. She could take 2 hours times the 125 and then add the $95. That's the total amount of money she makes. So let's take a look and see which one's true. A house call fee costs $95. That is absolutely true. She comes to the house, enters the door, $95 in her pocket. The plumber charges $125 an hour. Yes, that is true, because it says it right there, 125. That is 125, and the T is per hour, so that's true. The number of hours the job takes is represented by the letter T. That is true. So all of these answers are correct. Your answer is choice 4. Moving on to number 10. What is the domain of the relation shown below? So the domain, you should know by now, that the domain are your x values. So we're looking at the 4, the 1, the 0, the 1, and the 4. You could get rid of the 1 and the 4 again because you don't need to write it twice. If it repeats, doesn't matter. Who cares? Your answer is 0, 1, 4. 0, 1, 4. Your answer is choice 1. Pretty simple. Moving on to number 11. What is the solution to the inequality 2 plus 4/9 x is greater than or equal to 4 plus x? We got a bunch of fractions here. Don't be scared about fractions. It's really not that bad. So, let me rewrite this. Here we go. So, I'm going to subtract the 2 on both sides. We get 4/9 x is greater than or equal to 2 plus x. So, here's the best thing to do in this case. Either you could use the calculator and just subtract the x on both sides and you do 4/9 minus 1. Or, a little trick that always helps. You see how the denominator is a 9, and that's 4/9, and this has the number 1 in the front? Well, would you agree with me that the number 1 in the front of that x could be written as 9/9? 9 divided by 9 is just 1. And what's nice is that the 9/9, it has the common denominator with this fraction over here. So what you could really do is you could rewrite this as 4/9 x is greater than or equal to 2 plus 9/9 x. Just a little trick that could help you. If you don't like that, then that's perfectly fine. You can just subtract the 1. So we're going to subtract the 9/9 x. Subtract the 9/9 x. That cancels. We get negative 5/9. Now that's just easy. You leave the denominators the same and you just do 4 minus 9, negative 5. So negative 5/9 x is greater than or equal to 2. Now you're going to multiply by the reciprocal to get rid of that negative 5/9. So you multiply by negative 9 over 5. Negative 9 over 5. That cancels. Now when you multiply on both sides and you multiply this by a negative, you got to switch the sign. It's just like when you divide by a negative, you got to switch that sign. So this becomes x is less than or equal to 2 times negative 9/5. That's just negative 18/5. If you plug that into your calculator, that is your answer. X is less than or equal to negative 18 over 5. Your answer is choice 1. Okay? Pretty simple. Last question of this video, number 12. Konnor wants to burn 250 calories while exercising for 45 minutes at the gym. On the treadmill, he could burn 6 calories a minute. On the stationary bike, he could burn 5 calories a minute. If T represents the number of minutes on the treadmill and B represents the number of minutes on the stationary bike, which expression represents the number of calories that Konnor could burn on the stationary bike? They give you a lot of useless information here. Because look at the question here. This is just a reading question. Look, it says, which expression represents the number of calories that Konnor can burn on the stationary bike? Yeah, they did that to you. We don't give a damn about the treadmill. So anything that says treadmill, get rid of it. Please, please, please. Look, the treadmill can be represented by... Yeah, so T represents the number of minutes on a treadmill. So if T represents the treadmill, get rid of any answer that has T. Oh, okay, I said that for nothing. So there are no T's in the answer. So get rid of the calorie. We don't care about the calories on the treadmill. We only care about the stationary bike. Doesn't matter, blah, blah, blah. Who cares? Okay. So which expression represents the number of calories that Konnor could burn on the stationary bike? So, it says here that Konnor could burn 5 calories a minute. So basically, you're just taking 5 calories and you're multiplying by the number of minutes on the stationary bike. So the answer is choice 2. Pretty simple. You're just taking the 5 calories a minute times the amount of minutes that he works out. That's the amount of calories that you burn. So let's just say he works out for 100 minutes, which is 1 hour and 40 minutes. He will burn a total of 500 calories. And that's how you calculate. Your answer is choice 2. Honestly, I didn't think that was a bad question, but I don't like how they threw in treadmill when it's not even necessary. All right, that is the conclusion of this video. I hope that was helpful. Make sure that you hit that subscribe button down below. Visit my website at www.nysmathreadersprep.com. Consider becoming a patron on my Patreon page. I will be forever so grateful, and you have my undying gratitude if you do that for me. And I hope to see you soon. The next video is Algebra 1 Common Core, 13 through 24 of this exam. See you soon.